Real quick introduction to radar here. As you know, radar gathers information about wind speed, direction, and reflectivity. It does this using sound waves that bounce back. And one thing you might not know is it tilts while it does it, up and down and vertical axis as well. And by tilting up and down, we get cross sections of the storm at different levels of the storm. So as you go through these, you'll notice there are different angles of elevation, and that helps us see different elements of the storm. And that might help us deduce kind of what happened here, because the storm definitely did not show standard characteristics of a tornado, that is a strong couplet and mesocyclone, but does show up in key little spots. So we're going to start off here looking at the 0.5 degree reflectivity, which is a normal radar, and here's the time I think the tornado was passing. You can see there's a nice little outflow boundary visible, and that's about it. So that's all there is at this level. And now take a look at the 1.45 degree reflectivity. You'll note that the storm is moving through. And the main thing to look at here is that the most intense part of the thunderstorm does appear to be shifting to the northeast. This trend will continue as it goes on. And now looking at the 2.4 degree, it's pretty clear that the storm is also still shifting to the east at the time the tornado is visible here. And that trend does seem to continue as the storm moves to the north. And now with the 3.35, which you're seeing the anvils of the storm. Again, nothing even close to interesting on this picture. And now for the composite, where we took the maxes from each reflectivity and combined them, and you can see a pretty good illustration of the storm dying and then lifting to the north. And this is probably the best reflectivity visible from the time. This is the 1 degree reflectivity from KCI. It's clearly high resolution. You can see here there's a nice view of the storm structure, including a nice hook there by Lansing. And as that storm moves on, you see it fragments, eventually forming a nice little bow echo outflow in the northwest corner of the city, visible there. And as that propagates, it does appear to interact with the main storm here, which is the time of the intercept at 41 UTC. And you can definitely say this is the best view of the storm structure at the time. And as that outflow interacts, you can see it starts to kill the original supercell, lifting north, forming a new storm, which eventually produced a spotter-confirmed tornado just north of Plattsburgh. A nice little inflow band visible there. And here we're looking a little lower in the storm with a 0.2 degree reflectivity. Not as much to see here, but a better view of the hook. Here it is propagating inward. The storm doesn't look as elemental as it did earlier. As you can see, this is the 41 UTC, which is when the intercept should have happened, and there are very clearly two inflow-outflow boundaries there, which is probably what caused the rotation. And as the storms lift northward, you can see a nice little inflow band of cumulus form. Now we're going to take a look at some rotational velocities. This is the base relative velocity, and it's good to see the couplet that was there earlier. Although there's nothing to see, really. There's a little wind change here at 0.41, which is when I think the storm moved through the area. Look a little higher, lower at 0.5 degrees, you can see the couplet more visible. This is the only visible shear at this resolution, and there's not really even shear there, so it's quite interesting. And as it passed through, this is when, again, you should have seen the rotation, and there's not even really visible shear on this radar. And as that moves north, there is an intensification of wind speed. Here's some high-resolution data. This is probably the best view of the shear that would have been available at the time. You can clearly see there's a strong rotation there that's about to cross 169, and then as it does, this is 0.41, which is the time of the tornado, I believe. You'll see there is rotation visible, and this is probably the wall cloud that we're seeing. And as that moves off, it does weaken appreciably, although there's still strong winds associated with it. Looking a little higher in the storm with the 0.10, we're seeing that this rotation extended into the supercell. It does not appear to, although you can see there is some, at least, change in wind speed as it approaches 169 here. Moving forward, you see that speed is weakening, so it would appear that whatever was causing that rotation, or at least shear difference, is weakening. And at 0.41, which is when, again, the tornado should have been occurring, I don't really see much of anything there except just strong winds. That does move off to the north, and does look to intensify as it wraps into those new storms. Looking a little higher again at 1.8, we're missing a little data, but we can extrapolate that there's really not a whole lot happening there. Here's the 0.41 when I believe the tornado was moving through, and again, there's really no visible couplet. Interestingly enough, though, you can see the new cells are producing some higher wind speeds in this with the blues. And here, looking at the 0.5 degree storm relative velocities, you'll see the couplet does appear to live a little longer, although it does die off at the time of tornado here when there's just a change in wind speed. We call it a higher resolution. This did appear to have strong shear. And looking a little higher in the storm again, it's clear that this rotation was basically confined to the lowest levels of the storm. There is a couplet that does appear to die off. And at the time of tornado, again, just a slight intensification of winds where the wall cloud should have been visible. And we're going to look higher in the storm yet again at the 2.4 degree. And here you can see there appears to be at least a little bit of an intensification in winds, but again, definitely no couplet. This was actually the main radar I used to diagnose the storm at the time. And now looking at the highest level of the storm relative, again, you will see there is not much of a signature at all. You do see that there's intensification of winds here at the tornado. But again, nothing really all that interesting. Real quickly, we're just going to take a look at the echo top. So the top of the storm is determined by radar. Interestingly enough, you'll note the storm is dying and is centered around 50,000 feet throughout the time, even though it would appear that the storm is losing height. Now we're going to take a look at the vertically integrated liquid, or VIL. Good indication of storm strength and hail, and you can see clearly that the storm was dying. And the eventual intensification of the storm to the north into quite a complex downturn. And here's a synoptic view of what was happening, just a good radar loop of the time, and the high resolution at the time. Again, you can see this nice storm, and then a second storm by Tonganoxie that was also tornadic. And here's the image you sent me, and not horribly visible there, but it is, clearly a rotation. And then with a little bit of doctoring digitally, you can clearly see that it is separate from the rest of the cloud. So pretty much looks like you saw the right thing.